Here is an interesting form of construction I found in one of my older construction books, and you can probably see why it's not used today. However, I will provide you with a little more information on why you might not use this at the end of the video. And according to the book, they used this method so they could use shorter boards. And I'm not about to suggest this method wouldn't work if the joists were spaced closer together and you weren't going to be dealing with any heavy structural loads that would have created problems for this type of floor framing. And you could use some type of a gusset plywood construction standard lumber, and I'm guessing even some type of building hardware might work to connect the two joists together. And of course, these breaks will be staggered to increase the floor strength. And the joists here are 24 inches on center, sitting on top of a beam that was created by 3 separate boards that would have been nailed together. And you can see here where everything is nice and straight. And for those of you wondering what in the heck these are and why the other side isn't blocked, that's because some of these older floors weren't blocked around the perimeter. And if they were, then it wouldn't be uncommon to have a block like this so that you could install some type of a vent here for the crawl space ventilation. And of course, we can't forget the support posts that would have been sitting directly on top of the concrete with no nails or even a block of wood underneath the post. And believe it or not, the support posts would have simply been nailed to the beam without any building hardware and rarely had any problems with this type of construction. Even in earthquake country where I live, I never went to a job to fix the post to beam or the post to the footing connection. Never once. And I'm not about to suggest that nobody ever had to do these types of repairs. Just that I never had to do them. Now, these beams that were made by attaching 2 or 3 boards together might not have ever had a break installed directly over a post like we're looking at here. And again, I rarely came to a project that ever had problems due to the fact that the beam was built, however, would have had problems from these sagging if the lumber wasn't large enough. And of course, I am not promoting that you do any of this type of construction. I'm just making the video to provide you with an example of how something might have been built in the late 1800s or the early 1900s. Now let's go ahead and talk about one of the problems you could have with this type of floor framing. And that would be the fact that if any of the joists ever sagged, then it could create a problem for the other side, especially if it's built with crowned or sagging lumber to start with. So here you can see where I left this board alone. This board here is at the original height of the floor to create a flat, level surface. However, if we bring it up, it is no longer going to be level, and we are not going to have a flat and level floor. And the same problem is going to exist if the crown is up. If we crown this board up, then this board here is going to be a little bit lower. And this isn't the only reason why they didn't use this type of floor framing system. Because if you think about it, you won't have to worry about the joist sagging and then affecting the other side if both of the joists are sitting directly over a load-bearing beam or wall. So again, just kind of throwing something out there that might be of an interest to some of you, especially those who are interested in the history of construction like myself. And let us know if you've had any experience with this type of construction, or if there might be additional problems that I might not have mentioned in the video. In this video, I will try and provide you with a better connection, or at least in my opinion, it's going to be a better connection for a shear wall that's going to have hold downs that are going to connect through the floor to the building foundation. And I've used this method before, but since I found a better method, I probably will not be using this method again unless it was specifically specified by a structural engineer. because I would rather connect the 4x4 to the building foundation. So simply lower the hold down and the post instead of having it like this. And one of the problems you're going to have if you do something like this and you use the anchor bolt required by the manufacturer of the hold down will be that it might not be embedded into the concrete far enough if you actually do it this way, which you're not going to. Most people are not going to do something like this because it's not going to meet the manufacturer's requirements. So that what they'll do instead is lower the anchor bolt so that it does meet the manufacturer's installation instructions, and then add a coupler or a coupling to it. However, you will need to check with the manufacturer to make sure that you can use a coupler for something like this. I would imagine with larger hold downs, you might not be able to use a connector. So make sure that you run this by your structural engineer also. Don't just rely on the manufacturer. And yes, I've seen problems created by using couplers on the jobs. So just don't rely on the manufacturer for something like this. Check with the engineer whose name is on the building plans. And again, do not get a verbal okay from this. Make sure that you have something in writing. Otherwise, you are going to be paying for any repairs and not the person who okayed this over the phone. Another thing you might be able to do, and this might be on your building plans as another alternative also, would be to use a longer connector like an all-thread that's going to have something like this on the bottom. You might have a nut on the top with a large square washer and another nut on the bottom that can be firmly embedded into the concrete. And again, I got to stress this. This might not be an approved construction method for your project. However, if it is, make sure that you add a block, something like this, in the floor framing to get some additional structural support for the hold down going through the floor framing. Next up, let's go ahead and take a look at the method I like the best. And again, that would be running the 4x4 down to the top of the sill plate that will be sitting directly on top of the building foundation. And with this method here, you're not going to need a coupling or the all thread. And in my opinion, you're going to create a stronger shear wall because now you're not going to be relying on a load transfer through the floor framing. Now keep in mind that something like this is going to be a little more difficult for the framing contractor to build and might require a few more dollars. So it wouldn't be a bad idea to figure out the cost difference between doing something like this on a project that might have a lot of hold downs. Another thing you're going to need to do will be to add a block, and that block should extend a little bit past both sides of the 4x4. And let's go ahead and take away the wall framing plates to give you an idea of what something like this is going to look like before you lay out and frame the walls. And in some situations, even though I've never ran into this, you might need to use both methods. Connect one to the foundation, one to the floor framing in order to avoid a specific problem you're going to run into on your project. Now, another thing that's going to add a few more dollars to your project will be the longer shear panel or the additional amount of shear panel required to extend the shear wall all the way down to the building foundation. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood framed floor, because either you or the architect think that this is a superior design. I cannot see it. I'm never going to see it, and I'm never going to agree to it, even though I saw this design on almost every set of building plans I worked with. I never used it. I never used it, my dad never used it, and there's no way I'm ever planning on using it because it just doesn't make sense, and the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to two base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed, and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use two framing plates that you can use to attach the stringers securely to the foundation, and have your notch here to prevent the stairs from sliding forward, to prevent the stringers from sliding forward. If this is actually something you believe will happen, again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up, and that's probably not going to happen if you have enough base framing anchors to prevent that from happening. Here is another one of those rules that most home builders and framing carpenters aren't really aware of. And I don't think I knew about it until I was in my 30s. And it has to do with rafter ties or ceiling joist. And this would be with any connection to the roof rafter or any lapse that you're going to have between the ceiling joist or the rafter ties. And that's going to be the amount of nails required per connection. And according to one of the charts I found, this could be anywhere between 3 16D common nails and 51 16D common nails. And a common nail is larger than a sinker. And with that being said, the more nails you put into a piece of wood, the greater the chances it's going to split. And I really don't know where the thinking is behind something like this, but I can tell you that you can install the nails on both sides if you need to, and you can use larger lumber if you need to. If you need to put 51 nails into a roof rafter and a rafter tie or ceiling joist, you're probably going to need 2x12s for both of them. Now, how do you find out how many nails you're going to need? Simply go to your favorite search engine and type in the words ceiling joist and rafter tie connections. And it should take you to a chart. And in the chart, you're going to look for your rafter slope, how far apart the rafter ties or ceiling joist are going to be spaced, or their on-center spacing, then the live load or the snow loads, and then the span of the building. And to provide you a couple of examples, if I had a 3 and 12 roof pitch, and I was going to space my rafter ties 48 inches on center for a regular roof without a snow load, or a live load only, on a building with a 12-foot or less span, I would need 10 16D common nails per connection. If that building was going to be between 12 and 24 feet, I would need 20 nails. And this is where it goes all the way up to 51 nails. If I was going to space my ceiling joist or rafter ties 48 inches on center, I would need 51 nails per connection if my building was going to be 36 feet wide. However, if I was going to space them 16 inches on center on a 36-foot wide building, I could reduce that from 51 to 17 nails per connection. And hopefully that makes sense. However, if you have any problems using the information in this video, feel free to let us know in the comment area, and I'll see if I can provide you with a little more guidance on this subject. In this video, I will provide you with 5 common mistakes do-it-yourselfers make when fixing sagging floor framing. And first on the list, you got to figure out what caused the problem in the first place. And even though I'm not going to be able to provide you with every single method to check these problems, I will be glad to create a video checklist if you need one. Just let us know in the comment area. So the first thing you might want to look for will be excessive soil erosion or soil settlement. And this will probably happen around the supporting piers. And you might be able to find that by just simply noticing excessive moisture in the soil. Next up on the list, and this is going to be another one that's going to be difficult to figure out, would be excessive moisture in the crawl space. And a sign of that might be wet lumber. The floor could also be sagging because of excessive weight, like for example a waterbed, piano, or maybe a library filled with books that could be located in the middle of the unsupported floor. Another problem could be from termites or wood rot, undersized floor joist, incorrect installation methods by the floor framers, bad lumber. For example, you have lumber with a lot of knots in it, or it could be cracking and splitting. And last on the list, your floor sheathing might be too thin. Number 2, and next up on our list, will be undersized repair footings and beams. And I can't tell you how many times I see a 4x6 that's 16 foot long with a post and a support footing at each end, when in reality, something like this might require a 4x10 or a 4x12, or an additional footing or pier in the middle, or even 2 more instead of 1 spaced evenly in between the 2 outside posts. And of course the old, I'm just going to go ahead and set my post on top of a couple of blocks or bricks, might not work either, along with smaller footings. Now for a single story house, it's not uncommon to have a 12 by 12, 12 inches deep concrete footing, where the top of the concrete footing will be at least 6 inches above the soil. However, in your area, they might be able to be larger or smaller. I won't be able to provide you with the exact sizes. However, this right here usually isn't going to work, especially if it's not going to be sitting on well-compacted soil, which is another reason why you're probably going to dig a little bit deeper for your footing. Next up on the list, and this is another biggie, this is probably the biggest one that I come across when watching other videos or answering questions in the comment area, and that will be using undersized floor joists. If your joists are sagging already and you have a 2x6, then you might need a 2x8, and by attaching a new 2x6 to an old 2x6 that has already failed might not provide you with the best option. If you could remove that joist and install a 4x6 or 2 new 2x6s you're going to nail together, then you might have a good repair. But by nailing a new board to an old board that is already undersized might not provide you with the best option either. And of course, in a situation like this, I would install a beam in the center. I wouldn't even bother with sistering the joist. But I do understand that you will run into a situation where your only alternative will be to add an additional joist. And if that's the case, you might want to use a wider piece of lumber like a 3x6, a 4x6, or even a 6x6. Another mistake I see a little more often than I would like to would be when someone is dealing with joists that might be spaced 24 inches on center, 32 inches on center, or 4 foot on center. And to fix it, they want to sister a joist next to the existing one. And I'm not about to suggest that won't help, but you're going to be better off if you add another joist or two in the middle, or even use larger lumber. Here we have a 3x6 instead of a 2x6. And number 5 on our list, and something that some of us really don't think about until it's too late, and that will be to actually create a repair plan. And I hate to say it, but this is probably the absolute most important one on this list. And how do I know this? Again, because of the comments I get or the emails that are sent to me when someone is telling me that they can't actually get to the repair. Or worse than that, they can't actually get any lumber into the crawl space area or get long enough lumber into the crawl space area to make the repairs. So make sure that you actually have access to the crawl space through an access opening. And if you need to make it larger, you might have to make it larger. And if you need to remove some of the soil in the crawl space, you might have to do that also. I've seen building foundations like this where you barely have 10 or 12 inches in between the bottom of the joist and the top of the soil. And as you probably guessed it, I turned those jobs down because I couldn't even get under the house to access the damage. And you might even be able to cut an access hole in the floor sheathing or remove a large section of the floor sheathing to access the area a little more easily. And a few other things to consider when planning will be whether or not you're claustrophobic, can deal with rodents or other pests that might be living underneath the floor, whether there's going to be enough ventilation and air that you can breathe. Is it going to be a little too dusty or have too many particles in the air? You might need a mask. And are you going to be able to get electricity into that area if you're going to be using power tools? In this video, we will be taking a look at some plumbing fittings that you can use to hook sinks up that are going to be back to back. So a sink located in one bathroom and then a sink located directly on the other side in another bathroom. And before we do that, let's take a look at the standard SAN-T connection with a single pipe being used as the drain and a single pipe being used as a vent, and then a single pipe to hook the sink up or the fixture. And you can see here where the single pipe vent is going through the roof and then the drain is going to connect to the other drainage pipes in the house. And if I want to have the two sinks connecting to a single drain line and a single vent pipe, then you might be able to use what is often referred to as a fixture T. And even though I'm using the double sinks as an example, other fixtures can be connected to a double fixture T. And the difference between this fitting here and a double SAN-T is that it usually has enough curve to prevent the water from this side while it's draining to actually go to the other side. However, that might not be the case if you use a double sanitary T, especially if you're using this type of connection for toilets that are going to be throwing out a little more water, whereas in a sink or a bathtub, you might not have enough water to actually make it across. And even if it did, it's probably not going to be enough. I really don't see a big deal with using a double SAN-T for a bathroom sink. However, I do understand that something like this could be a big problem if you're trying to use a snake to clean out the sewer. If you could imagine removing this section of the sink so that you could get the snake through here and hope that it's going to go down, but in reality, it's probably going to go across. And almost every plumber has a story about the snake going into another room and creating problems for the bathroom on the other side of the wall. And another fitting you're probably not going to be able to use for a situation where you have two fixtures on each side will be a situation where you have a Y fitting like this, connecting to your sink with a 45-degree fitting. Your local building codes probably won't approve it because this could create a water siphoning action that could pull water out of the trap. How much water? Would it be enough to ever create a problem? Might depend upon the distance between the fixtures, the amount of water coming out of each one of those fixtures, and the diameter of the pipes connecting the fixtures together, with a single drain pipe and a single vent pipe. And of course, a setup you're probably never going to have a problem with will be to connect each sink to a separate drain line, which will connect eventually to a single drain line. And I've actually ran into situations before where certain cities only allowed this type of setup. And again, you're not going to have a problem if you need to run a snake through something like this, because it's not going to be going across a double fitting, even though I don't think you're ever going to have a problem if you use a double fixture fitting, because they're designed specifically for that purpose. And since we're using the double drains, we're going to need 2 vents or 1 vent for each fixture, and we can connect one of them into a single vent pipe as long as all of the pipe sizes are the correct diameter. And don't forget to turn the sanitary tee upside down. And with this method here, we're not going to be able to come straight out of the wall at a 90-degree angle if each one of these sinks need to be positioned directly across from each other. And to fix this, all we need to do is rotate one of the fittings or both of the fittings just a little bit. And in this case here, I just went ahead and rotated this one a little bit. And most of the time, this won't be that big of a deal. I know I've made plenty of videos where I've rotated this fitting about 45 degrees and had complaints from people suggesting that the pipe has to come out at a 90-degree angle. However, in my designs, I'm choosing to eliminate as many bends or angles as I possibly can, and that's one way to do it. And the last thing I want to mention will be that if you can lower one of the drain lines or raise one, then you might be able to use this method here, with one sanitary tee fitting above another sanitary tee fitting, and again using the single drain line with a single vent. And to make something like this work with both of the sinks at the same level or positioned at the same height, then you're probably going to need an extender. And that's not that big of a deal. I've used plenty of them before because of customer design changes. And I might as well admit it, I've had to use them more times than I've wanted to because I didn't locate these stub outs at the right height. And if I've done my job right, you now have a better idea about what you might be able to do and might not be able to do if you're not going to check with your local building department to hook a set of double fixtures together that need to be located on the opposite sides. Here's another one of those crazy ideas I found on YouTube that I don't think is going to work. And I'm not about to suggest that you can't do this in a different way, but I am about to suggest that I have a few things you need to think about before stacking a bunch of concrete bags on top of each other to create a retaining wall. Now, maybe if you're going to use this for 6 rows or less, 6 rows of concrete bags, maybe you're not going to have a problem. And maybe if you stack them differently, you might not have a problem. But what I'm about to show you here should provide you with everything you need to know about why your large retaining wall built out of concrete bags probably isn't going to work. So let's take a look at a regular retaining wall. It's usually going to be built something like this. It's going to have a large footing with a bunch of rebar in it to prevent the soil or the moisture in the soil from pushing the wall over. And I don't know how you're going to do that just by stacking bags on top of each other. So even if the bags were to hold, you're still going to be dealing with the pressure from the soil behind the bags. And in reality, that's all you need to know for the video. You can stop watching it right here, because I don't think by rearranging the bags somehow you're going to solve this problem. And of course, we can take a look at what the wall's eventually going to look like after the paper wears off, which might not be a big deal, except for the mess that it's going to make on your property. And another problem you could deal with will be tree roots. And trust me, the tree roots will love a wall like this where they can get the roots in between the bags. And then, of course, do what they do best, and that will be to get a little larger over time and speed up the process of destroying a wall like this. So what if we go ahead and put some plastic or some type of a moisture barrier behind the bags of concrete? Will this solve our problem? Probably not. Again, we don't have the large footing like we have over here, or a structurally reinforced solid wall. And even if we can prevent the tree roots or moisture from coming through here, we might not be able to prevent it from going underneath or prevent the massive amount of soil behind the retaining wall from pushing this thing over. And if you do use the plastic, you're going to have to make sure that it is positioned in a way to eliminate all of the moisture from coming through and not just some of it. Because in a situation like this, all of the moisture that settles on the ground in front of the retaining wall can soak up into the lower section. The moisture that's behind the top of the retaining wall can go around it if the moisture barrier isn't tall enough. And I'm not about to suggest that trapping the moisture behind the retaining wall is going to be a good idea either. It could increase the force behind the retaining wall and cause it to fail. And an example of that might look something like this, where we have the wall tilting forward at the top. Another thing most retaining walls will have will be a gravel-lined section behind it and some type of a drainage system that will allow the water that gets trapped behind the retaining wall to be removed from this area. Another thing I would like to point out is that the back of the retaining wall is usually going to have some type of waterproofing material to prevent moisture from absorbing into the retaining wall from this side. And for those of you who want to build this wall out of your concrete bags anyway, and you're thinking, hey, why don't I just install the gravel behind my concrete bags along with my drainage system? And that's probably not going to work. You can remove the water. You can prevent the tree roots from entering into the bags, along with the water that's going to be trying to go around this thing, will usually be enough to destroy a taller wall. And I don't know what the height of that wall would be, but I can tell you that something like this is going to work a lot better than something a little taller. Now, I wouldn't use this method, period. This would not be something I would be using for a straight retaining wall. I've seen this done on curved retaining walls. You might have a better chance at something like that working than you will a straight wall, because I've seen small retaining walls built out of sandbags before that seem to work pretty good until the canvas surrounding the sandbag starts to fall apart. Let's start this video off by explaining the difference between a dry mix of concrete and a wet mix of concrete. The dry mix would be something that you have not added water to before placing it in the forms, and a wet mix would be something you've added water to and mixed thoroughly before placing it into your forms. And this might sound weird, but this is actually what most of the directions are going to require when building anything out of concrete. However, there is one product I found that allows you to use a dry mixture. You're just simply allowed to pour the dry mix into a footing you're going to use for a fence post. And then after you've added the dry mix, you can thoroughly saturate it with water. Then you're going to get the chemical reaction you need to make the concrete hard. And of course, the reason why I'm making this video is because I found a couple of people on the internet claiming that you could just simply fill the areas in between your form boards with a dry mix of concrete and then wetting it, thoroughly soaking the water into the concrete mix to get the chemical reaction required to make the concrete hard. Now, I don't know if this is going to create something strong enough for your project, but I can tell you that something like this probably won't work for a walkway or a porch, especially if we remove the forms. If you pour the mix and leave the forms, you're going to have a protective barrier around the perimeter. However, once you remove the forms, over time, you could end up cracking a section off of the side that would look something like this. And I'm also not going to suggest that something like this couldn't happen to a mix that you mixed thoroughly before pouring. So to wrap this video up, this is not something I recommend doing. follow the directions on the concrete bag. And if you're looking for a little more structural strength, add some rebar. And make sure that all of your concrete is poured on a solid, compacted fill material, not loose soil. Here is a follow-up video to a video I made about a week ago about whether or not to use a dry concrete mix instead of a wet concrete mix for your small projects. And are going to try using this dry pour method anyway. Now, the number one problem I see on the internet that has a high probability of failure, whether you're using a dry mix or a wet mix, will be to make the concrete pads at least 3.5 inches thick. Because I've already seen a couple that turned out just fine in the video, but I don't think are going to work in the long run. My next idea would be to raise the form boards up a little bit so that when you're watering your concrete slab, that it will create some type of a container that will allow most of the water to go through the concrete. Because there were a couple of videos that I came across with a concrete slab that wasn't very strong because the water hadn't soaked through it. And if you don't raise the forms, it wouldn't be a bad idea to be careful when you're wetting the concrete to prevent any water from going over the edge of the form boards. Because if water's going over the form boards, there's a good chance that the cement is also going over the form boards, and that's not going to help your finish. Now, if you do want a smoother finish, here's something else that might work. And that would be to screed all of the rocks down to where they're about 1/8 of an inch or 1/4 of an inch lower than the form boards. And then add a layer of Portland cement. The Portland cement should allow you to get a smoother finish or even a nicer broom finish if that's something you're interested in doing. If not, then you could end up with a rougher finish. But again, this might not be a problem for you, especially if you're not planning on finishing the concrete at all with any types of trowels to smooth out the concrete or to round off the edges. Another thing I would definitely suggest doing, I just watched a video where somebody placed a dry mix on top of some wood chips. And over time, these wood chips can decompose and create a void or an area that's underneath your concrete that will no longer be supporting the concrete pad. Make sure that everything you build is on top of a solid foundation or well-compacted soil. I cannot stress this enough, because if you're looking for cracks, soil erosion, tree roots, and uncompacted soil are probably going to be at the top of the list. And of course, why not throw some rebar in there or some type of a wire mesh, something that you're going to use for a wet concrete mix to see if that will help increase the strength. And if you're using a 3.5 inch thick slab, the rebar will be placed somewhere in the center. And you could probably position the rebar after filling up about 1 inch, 1.5 inches of dry mix in your forms, and then simply setting the rebar on top of that and then filling it up the rest of the way. And the last thing I want to point out is that most of these pre-mix bags are rated at about 2,000 to 2,500 pounds per square inch. Here's what a square inch looks like, 1 inch by 1 inch. Even if you're only getting 500 pounds per square inch with your dry mix concrete, that might be enough for your project. So keep that in mind also. Now, the last thing I want to say in this video is that I am not 100% convinced that we need to hit something like this with a sledgehammer or drive a truck over it. Because if all you're going to do is put a chicken coop on top of it, and you're never or rarely ever going to step on it, then something like this might work fine. But if you're going to do that, why not just form something up and fill it with gravel and avoid using concrete, whether wet or dry mixed? And for me, I'm not 100% convinced that this is the best way to go for anything, including a small concrete pad, until one of these products tells you in their directions that you're allowed to use the dry pour concrete method and tells you what you can use that method for. In this video, I will provide you with what I think might be the easiest method you can use to design a geodesic dome type structure. And if you want to see more videos like this, let me know in the comment area. If I don't really see that big of an interest, then I'll just kind of filter these babies out when I feel like it, or put them on one of my other channels. So let's go ahead and get started with a 6-sided figure and 6 equilateral triangles. Each one of these triangles will have the same length and the same degrees. In our example here, however, that might not be the case. So I'm going to start with one flat shape here. This is not going to have any slope to it, along with 3 footings. And I'll provide you with, again, a simple method for locating the footings. And keep in mind that this is the center point of the building, and most of the measurements are going to be taken from this point. Next up, we're going to take this design and create 4 of them, one for the top and then one for 3 sides of the building. And again, keep in mind, I'm still working with flat surfaces here, and we can make the footings taller or shorter if we need a little more height in our building. So not too difficult, I would imagine. Then we're going to fill in these areas here with 2 identical shapes over here, and then a plumb surface here. This wall right here will be used for our doors and windows because it's going to be difficult to put them anywhere else. And that's the beauty of this design here. Instead of having a bunch of angles that will make it difficult for us to install windows and doors in. Next up, let's go ahead and pop the center out a little bit to give us some shape. Now I moved the center out 1 foot to provide us with some slope and something that's going to help our building look more like a geodesic dome than if we leave it flat. And I'm not sure how much further this section needs to extend up. And I don't know if you could actually build something like this with a flat surface, because if you could build this with a flat surface, and obviously that would be without the exception of the roof, we're going to need some type of a pitch up here to shed water off of the top. However, once we get to the sides here, if we could actually create a flat surface, that would be a lot easier for us to install shingles or other roofing components instead of having individual shapes that we're going to have to deal with here. Again, we can't keep the top of the roof flat. However, it seems like we could keep these 3 surfaces flat if that wasn't going to create an engineering problem for our geodesic dome. Keep in mind, I'm just throwing this idea out here and will not be able to provide you with any structural engineering information. However, I will be providing you with construction information, framing information in future videos. So let's go ahead and throw some measurements out here. 10-foot equal-sided triangles with 60-degree angles in every corner. So that would be a 60-degree angle here, 60-degree angle here, and here. And this will apply to each one of the triangles in this section. However, this might not work on your project. If you add some slope, you could change some of these angles slightly. Now here's something I found interesting in locating the footing. I do not know if this is going to work every single time. And keep in mind that the length of the footing should be equal to the length of this side. So you would have 3 of them the same size. And to create a 60-degree angle from the bottom, I realized when drawing this to scale, this measurement here, and that would be from this point here to the outer side of the footing, was exactly the same as this measurement here. And again, keep in mind, this is on a flat surface. This measurement would change if we put some slope or some pitch on each one of these angles here. However, this wouldn't be difficult to figure out if you're drawing this out on a piece of paper or in a CAD program. And the location of the footing can also be found by drawing a straight line or having a string run from the center point to this center point here. Remember, this is 5 foot on each side, and then going straight out. This is going to be the middle of the footing, and then the footing is going to be parallel to this line here. And of course, there might be an easier way to draw this or design it. And if I come up with one, I'll be glad to provide you with that information in the future. Here is another tip that might provide you with an alternative for installing your fence post for a wood fence. And I usually build my fences like this, to where the top 2x4 rails sit on top of the fence post. However, if I do that and the fence post rots at the bottom, I won't be able to use this next method. However, you would be if you allowed the fence post to extend beyond the top of the railing. And the reason why you might choose to do this is because when the fence post rots at the bottom, you can simply remove the concrete footing and then cut the bottom of the fence post. And you don't need to do it while it's attached to the fence. Otherwise, you won't be able to lower it into the hole so that you can reuse the old fence post. And of course, this method here will require you to disconnect it from the existing fence and might require you to install some bracing or supports to hold up both sides of the fence while you're working on reusing the old fence post. So not too difficult. And I've done this plenty of times. I usually do it when I come to a fence that I didn't build because, like I said, I like to have the railings sit on top of the wood fence post and will simply replace the post when I need to. However, with the price of lumber getting out of control, I might be building my next fence post with extended 4x4 posts sticking up past the top of the fencing. Here is another thing that I see stair builders doing that might not be necessary, and that would be adding more stringers or doubling up the stair stringers. And keep in mind that I will not be able to tell you whether or not you need to do this, but I can tell you that I see it plenty of times on the exterior of a building, and if it is, then you could end up with a water trap. And this would be a small gap that would allow water to get trapped in between the lumber. And I'm sure some of you have seen videos where you can put some type of a waterproof membrane on top of the double stringers. But that can also lead to a problem. So my suggestion would be to maybe add 1 or 2 washers in between the stringers and then go ahead and run a bolt through them. If you're looking for a stronger stringer, something like this is going to allow the water to drain out of the area in between the stringers. Or instead of doubling up the stringers, you can just simply lay them out a little different. However, something like this might require a few more nails and could make it difficult to create a straight line between the other stringers so that you don't end up with squeaking stairs. Or you can use larger lumber. You can use lumber that's going to be wider or taller. So instead of using a 2x12, you could always use a 4x12 or a 6x12, or use a 4x14 or a 6x14, or even a single 2x14 instead of a 2x12. And if that isn't working for you, then maybe you can use larger risers or even larger treads. And I'm not about to suggest that you use any of these methods in this video without considering the ultimate option of cutting a huge, massive tree down and carving your own stairway out of a solid piece of lumber. And of course, I'm just joking, because unless you're going to be installing a stairway that needs to be structurally stronger for an industrial or commercial building, for example, then you're probably going to be better off just using the standard construction practices that have been working just fine for decades. Here's another project for our garage with the loft above it. And in this one here, I will provide you with a double shed roof with a couple of gable roof sections on each side. And in this video, I'm not going to go over the entire process, just show you some of the modifications that you might need to do from a previous video that I did. And I will put a link to that video in the video description box, because I already built something like this with one shed dormer on one side, not a double shed dormer or one on each side. So let's go ahead and get started by removing the roof sheathing so that we can take a look at the modifications I would have made to the other side. And basically this section of the roof, the wall framing, the dormers, will be identical to the other side. And about the only difference between the two will be the rafters lapping over here and a section of the sheathing that I will be changing. And I will cover that at the end of the video. So let's go ahead and work our way around the building to where the rafters are lapping here. And you can see right here where they're lapping. And these rafters are 16 inches on center. And since we're dealing with a low sloping roof, the top of the blocks probably don't need to be shaped. However, you can shape them if you need to. And the lap will provide us with a nice structural tie between each side of the roof. We're going to nail into both sides of the rafters. Maybe put 4 nails on each side and then 4 nails going from the other side into this rafter. And then of course we will toe nail each rafter into the ridge beam. Go ahead and take a look at the other side of the lap there. Zoom out. And again, this video won't require that much attention to detail because I have most of the framing information in the other video. So again, this side right here will be the same as the other side. And of course, this will be a little different because we're dealing with the stairwell here. And I believe I provided you with 2 different methods you can use in the other video to frame one side with the rafters and the wall framing here. That will have a wall like this attached to the roof rafters. And the one on the other side will have the wall sitting on top of the roof rafters. And the wall framing for this wall should be the same on each side. And of course the walls here that will be sitting on top of the rafters and the roof sheathing. So we're going to install the sheathing here before we build our wall and then add our roof rafters to that wall. And I'll let you pick whatever method you choose to use for your project, just kind of throwing out some ideas as I do in most of my videos. Let's go ahead and install the fascia board. Throw the sheathing on and then kind of zoom into the area I was talking about. So you can install the roof sheathing this way. And again, I should have more information on that in the other video, where the roof sheathing goes underneath the wall framing here. However, leaves kind of a strange gap there. This one over here, this one here will be built a little different, where we're going to notch this section of the roof sheathing so that the new sheathing will be installed over it instead of notching around it. And I'm not just giving you a choice here on which one to use. I'm also providing you with an example of a problem that you might be dealing with if you use this type of construction, if your roof framing is identical to this project. And like I said, in the other video, you will have more information about the floor framing, wall framing, and sections of the roof. In this video, I will provide you with something that seems to be another problem for do-it-yourselfers, and that will be the difference between a horizontal and a vertical plumbing waste and drain connection. So let's go ahead and orient ourselves here with a situation where we have a toilet flange. Toilet will connect to this, and a bathroom sink, and how something like this would look if we remove all of the framing and the foundation. To take a look at our plumbing pipe. So here we have a vertical pipe connecting to a horizontal pipe. That makes sense. However, it gets a little more confusing when we start to angle or tilt some of these fittings a few degrees. And what we have here would be a wet vent connection. This is actually the vent for the toilet, and this is the vent for the sink. So the water is going to go down the sink, down the toilet's vent. This is why this is a wet vent. The reason why this needs to be horizontal is to allow air flow on top of the water. The water is going to flow near the bottom of the pipe, which will allow the air for the vent to flow above the pipe. However, it gets a little confusing once it gets to this area here. And I'm not going to go into a lot of details on that. But this is a horizontal connection. When you have a fitting connecting horizontally or level, and of course you can look at the example here, to create a better understanding of what I'm talking about. So horizontal to horizontal means that the fitting is going to be horizontal, or this part of the fitting will be level. And let's go ahead and pan out here so that you can get a better idea of where the vent is going. This part of the pipe will be going out of the top of the roof and can be plumb or vertical. This section of the pipe, wherever I'm referring to as horizontal, will need to slope towards the sewer or septic tank. And this will depend upon the pipe size. Could be anywhere from 1/8 of an inch to 1/4 of an inch minimum slope per foot. Next up, let's take a look at a vertical to a horizontal pipe connection. And in this situation here, this is now the drain pipe. This is the vent for the toilet. And the building code requires it to be vertical or at the most tilted about 45 degrees. And I'm not talking about this tilt right here. This is just a way of connecting the vent to the drain pipe. You can actually use a combo sweep connector like this to connect your vent to the drain line. And as you guessed it, the vertical to horizontal will actually be vertical, and we simply rotated the fitting 90 degrees from our previous example. And I went ahead and filled this up with drainage wastewater to give you an idea of how the water will flow near the bottom, allowing the air to flow above it to prevent it from creating any type of siphoning action or siphoning any of the water out of the other fixtures' traps. And the building code says that dry vents connecting to horizontal drain pipes shall connect above the center line of the horizontal drain pipe. And almost all of the plumbers that I've worked with suggest that this means this pipe right here cannot be rotated more than 45 degrees from its vertical position. However, with that said, I've actually seen plumbers rotate these pipes a lot further. I've seen them rotated just barely off of the horizontal position. So you might want to check with your local building department to see if that will be allowed in your area or allowed under certain special circumstances, because there will be situations where you're going to be working in tight spaces, like a floor where the floor joists might only be 5.5 inches tall. And this is usually where the floors get hacked up pretty bad by the plumbers. If you have a little more room, 11 or 12 inches, you can usually make this stuff work a little bit easier. So here's an example where we have a fitting at a 45-degree angle, and then the vent is going up. So you can see here where it's going up and above the center line of the other plumbing pipe it's connecting to. And again, the vent here is going out of the roof. And in this situation here, we have a separate vent for our toilet and a separate vent for our sink. And you can extend and modify the length of your vent pipe if it needs to go a little further so that it might be able to go up an interior or exterior wall. And in our last example here, I want to provide you with something else that plumbers do when attaching a wet vent to a drain pipe. You have a toilet coming up here, and when it is downstream or down from the sloping angle of the drain pipe, remember the pipe here is sloping towards the sewer or septic tank about 1/4 of an inch per foot. And when you have a situation like this, you can come up with a 90-degree fitting. And I would use a sweep fitting here or a long 90, because this is going to be a wet vent here for your sink. This is going to be the sink drain to here, and then the toilet drain and the sink drain from here. And then the vent for the toilet is going to go from here to here. It's going to be a wet vent. So if you're at the end of the line, you can come up with a 90. This is the only situation I've seen it happen with. Otherwise, make sure that you connect horizontal to horizontal when using a wet vent. In this video, I will provide you with an example of how you can build a floor cantilever on the side of the building where the joists are going to be running perpendicular. So for a cantilever on this side, we can simply extend the joist or attach new joists to the ones that are running parallel. However, we won't be able to do that if we want to put a cantilever on this side. And to do that, all we need to do is something like this. we can install our cantilevered joist perpendicular to the floor joist or at a 90-degree angle, and simply add a doubler here, and a doubler over here. And as far as the cantilever span, you might need to check with your local building department or engineers, because some of them might have a maximum of 1/3 of the distance or length of the cantilever joist, while others might have a maximum distance of 1/4. An example of that would be if this was a 1/3 cantilever and the length of this joist right here was 48 inches long, then we could cantilever out 16 inches or 1/3 of the length. However, if it was 1/4 and we had 48 inches or 4 feet, then the cantilever could only extend out 12 inches. So it wouldn't be a bad idea to check with local contractors, building authorities, or engineers before building or adding something like this to an existing home. And of course, we will use hangers to attach all of the joists that will require them. And of course, we will have a doubler, a double stud underneath all of our double floor joists. And I understand if you're remodeling something like this and it's a small cantilever, you might get away without putting them in there. However, as someone who tries to be a responsible educator in the construction field, I gotta point that out. Most engineers are going to require double wall framing studs underneath your double joist, and that will include the double joist you're going to be attaching the cantilever to. So another set of double studs, or even a post. You might want to put a post there, or your engineer might require you to put a post there. And the rim joist can be attached by using 16D nails. And if you have 2x10 or 2x12, you might want to use 4 nails per joist connection. And let's go ahead and wrap this video up by suggesting that if you have any questions or comments about the video, feel free to leave them in the comment area, and I will respond to them as soon as possible.